geometric sequences and series. A geometric sequence, they have what's called a common ratio. Arithmetic sequences have a common difference. These guys have a common ratio, which means if you take term 2 over term 1, you're going to get R. Term 3 over term 2, you'll get that same number, and so on through all the terms. That's what makes it common. Okay. If you have a geometric sequence, there is a special formula you can use to find the nth term. Now remember, the nth term is just writing the rule for the sequence. Okay, so a sub n, that means the nth term, is equal to a sub 1, which is the first term, times r to the n minus 1 power. When you're writing the nth term, n stays n, a sub n stays a sub n, and you plug in for a1 and r. Okay, so to determine if a series is geometric, that's what you do. You're going to take 27 over 81. That's going to equal 1/3. Do the same thing with the next one. 9 over 27. Oh, look, that equals 1/3. 3 over 9. That equals 1/3. 1 over 3. That is 1/3. Okay? This is a geometric sequence. Do you have to test them all? Yes, you have to test them all, because what if we got over here and this were a 2? Okay? Do you have to actually physically write it down when you're showing me? Can you do it in your head? Yeah, you could probably do this in your head. But don't just check the first one and say, okay, yeah, it's geometric. We're good. All right, writing the rule. So to write the rule, that means we're writing the nth term. So a sub n equals the first term times r to the n minus 1. A sub n stays a sub n, n stays n. You're plugging in for the first term, which is 81, and r, which is 1/3. So the nth term can be found by taking 81 times 1/3 to the n minus 1 power. Next one. Here I'm going to give you a term in the sequence and the common ratio. And I say write the rule and graph. Okay, well, to write the rule, we start by, okay, a sub n equals a1 times r to the n minus 1 power. Okay, well, 96 goes here for a sub n. The 6 is going to go in here for the n. And the 2 comes here for the r. And now you have everything you need, and you solve for the first term. So 96 equals a sub 1 times 2 to the 6 minus 1 power. Okay, so 96 equals the first term times 2 to the 5th power. 2 to the 5th power is 32. So 96 over 32 divided by equals the first term. So 96 divided by 32 is 3. Now the rule is a sub n equals 3 times 2 to the n minus 1 power. Now when you graph these are actually just plotting points. Okay? You're not actually going to draw a line or a curve. It's going to make the shape of a curve, but remember, your domain in a sequence are the consecutive integers. So none of the numbers in between, so it doesn't make any sense to connect the dots. So, make table values. We can call it x, y. X is going to be n. Put that there, and then this is going to be your term. Okay, remember, domain and range. X and y, domain and range. So 1, 2, 3, 4. We have number 6, and it's kind of a big number, so we probably won't use it. So 1 minus 1 is 0. 2 to the 0 power is 1. 1 times 3 is 3. Oh wait, we knew that. That's the first term. Silly. 2 minus 1 is 1. 2 to the first, this is 6. 3 minus 1 is 2. 2 squared is 4. 3 times 4 is 12. Okay, now I'm getting kind of big numbers. We could continue on, but they're getting very large very quickly. When we graph this, okay, the first term is 1, 3, then 2, 6, 3, 12. It's going up very quickly. Okay, on your regular graph paper, you'll see it much nicer. But I'm not connecting the dots. Okay, write the rule. This time I'm only going to give you 2 terms, and I'm not giving you the initial term, or the first term, or the common ratio. So what we do is we're going to use the formula a sub n equals a1 times r to the n minus 1. We're going to use this, we're going to write a system of equations again. Okay, a sub n is going to be negative 12, n is 2. Plug that in, and then we're left with a sub 1 and r for our variables. So we have negative 12 equals a sub 1 times r to the 2 minus 1, which is just the first power, so negative 12 equals a sub 1 times r. Let's solve for a sub 1 by dividing by r. So the first term is equal to negative 12 divided by r. Okay, we're going to use that in a minute. Right now we need to get a second equation because we've got 2 variables, we must have 2 equations. So let's say negative 3 must equal a sub 1 times r to the 4 minus 1 power. Negative 3 equals a sub 1 times r cubed. Well, we've got a sub 1 right here. We can substitute it into the other equation. Negative 3 equals negative 12 over r times r cubed. Well, what's going to happen with the r's? Okay, you guys know that. Negative 3 equals negative 12 r squared. Now we can solve. Divide by negative 12. We've got 1/4 equals r squared. Take the square root of both sides. R equals 1/2. Okay. Why not plus or minus? Well, we could try the plus or the minus when we're solving like we normally do, but if we plug it in, it's not going to work out because we're getting negative answers instead of every other. If r is negative, then we get a positive, a negative, a negative, a positive, a negative. It alternates. The signs alternate in your terms. So, now, back to the beginning. R equals 1/2. So the first term is going to be negative 24. Okay, so the first term in our sequence is negative 24. So our equation, or the nth term, is a sub n equals negative 24 times 1/2 to the n minus 1 power, and I ran out of space. Okay, so that's the nth term. Then to graph it, we just plot points like we did a minute ago. I think you guys can do that. A finite geometric series. There is a special formula. You need to know that. Okay, get that in your notes so you can use it later, but also put it to your memory. The sum of a finite geometric series, S sub n, is equal to a sub 1, the first term, times 1 minus r to the n over 1 minus r, where n is the number of terms in the series. Okay, if it's a finite series, then there's a definite number of terms there. So here's one we're going to find the sum for. We want the sum of the series defined by this equation, which is geometric. Okay, we're going to start at term 1 and stop at term 8. I'm not going to calculate all of the terms. I'm going to use this special formula. Okay, so to do this, it's going to be the first term. Well, the first term is when I equals 1. Well, 1 minus 1 is 0. Negative 2 to the 0 power is 1. 6 times 1 is 6. So that's going to be 6 times 1 minus r to the n, and we've got 8 terms here, so r to the 8th. Now r happens to be this negative 2, so negative 2 to the 8th power divided by 1 minus negative 2. Okay, simplify. We've got 6 times negative 2 to the 8th power is 256, so it's 1 minus 256 over 1 plus 2, which is 3. Okay, we go a step further. We've got 6 times negative 255 over 3. The 3 goes into the 6 2 times, so we've got 2 times negative 255. So this sum is equal to negative 510.